represent a linear function in table form. So remember that a linear equation, we're familiar with that, right? We think of y equals mx plus b, slope-intercept form. That's an equation because it has the equal sign. Well, a linear function is going to look very similar to that, but instead of y, we simply replace y with f of x. This means that this is a function of the variable x. So x is our input variable because you see it's in the middle of all the stuff on the right. So x is our input value, and f tells me this is a function, right? So it would pass the vertical line test. One thing to remember is that y is the same as f of x. Very important. Okay, so let's create a table of values for the function f of x equals 3x minus 4. Okay, so if we're going to create a table of values, we're going to have our input variable x and then our output f of x. If it makes you feel better, you can put y over here. It's fine. Those are the same. And then we say, okay, we need some values for x. Now, I generally like to go some negatives, some positives, a little bit of 0. And because we're here for fun, I'm going to go from -2 all the way up to +2. And what this tells us is these are the values for x. And we can input. So I'm going to look at 3x minus 4, but wherever I see x, I'm going to input that -2. So 3 times -2 minus 4. So -6 minus 4 is -10. Now let's plug in a -1. 3 times -1 minus 4. -3 minus 4 is -7. And we just keep doing this. So now we do 0. 3 times 0 minus 4. 0 minus 4 is -4. Now we can continue. Now one thing I do want to throw out is that you can also choose values for y. I think this is something we oftentimes forget. But what if I wanted to know when is my y value or my f of x value 0? So we just plug that in for the f of x. So I would say 0 equals 3x minus 4, and we solve for x. So I would add 4 to both sides, and I would get 3x equals 4. Divide both sides by 3, and x equals 4/3. Right? Fractions are fine. There's nothing wrong with fractions. They're numbers too. And then let's say, what if we wanted 8, just for fun, as a y value? So 8 equals 3x minus 4. Again, we add 4 to both sides. So 3x equals 12. Divide both sides by 3. And we get x equals 4. And there would be my table of values. So you can choose whether you pick values for x, pick values for y. Does not matter. I generally go with picking values for x because it's easier to shove things into the function there than it is to kind of solve the equation. But mathematically, they're both correct. All right, now let's consider the given table. Write a linear function to model the data given. Oh, a linear function. So now we are thinking along the lines of f of x equals mx plus b. Now, what do we know? Well, it depends if you've done slope or y-intercept yet, but we know that b is the y-intercept. The y-intercept means on my graph where the graph crosses the y-axis, meaning x is 0, because that's the only way you're going to get a value on the y-axis. So if I look at my table, x is 0 when y is 7. That means my b value for my equation is 7. Great. Okay, so I know that b is 7, and now I need to find my slope, right? Because m is slope. So hopefully you remember that slope is the change in y values. I don't want to write it like that. I want to write the change in y over the change in x. Now, if you know this is a linear table, then you could do the basic through 2 points. But if you're trying to decide if this is linear, you want to just look at the change in y. Meaning, as we go, so these, notice that your x values go by 1. That's something to also pay attention to. So as I go from 9 to 7, I subtract 2. 7 to 5, I subtract 2. 5 to 3, I subtract 2. So my change in y is -2. Now the change in x, as I go from -1 to 0, I add 1. From 0 to 1, I add 1. From 1 to 2, I add 1. So because these are both constant, right? Constant change is important. So change in y over change in x, -2 over 1, my slope is -2. So now I can write my linear function. F of x equals -2x plus 7. And that's how we can use a table to represent a linear function.